Hey guys, today we're going to do 5-4 dividing polynomials. Objective is to divide polynomials using long division. The essential understanding: you can divide polynomials using steps that are similar to long division steps that we would use to divide whole numbers. So if we are dividing long division with numbers, then we would have 21 as our divisor. And we would see how many times 21, or what times 21 would give us 672. So we can do the same thing with polynomials. However, now we are going to be using, we're going to be focused on our terms rather than numbers. If we have a remainder of 0, that means that the divisor is a factor of the dividend. So, using polynomial long division, we want to divide 4x squared plus 23x minus 16 by x plus 5. So, we are going to make our bracket. And here we're going to be focused on x. What do we need to multiply x by to get our first term, which is 4x squared? And that would be 4x. We're going to line up our powers, and now we're going to multiply 4x times x plus 5. So 4x times 5 is 20x, and 4x times x is 4x squared. We then subtract, and we get 23x minus 20x, which is 3x, and we can bring down our negative 16. Now, what do we need to multiply x by to get 3x? And we would have to multiply by 3. So now we take 3 and multiply it by x plus 5. So 3 times 5 is 15. 3 times x is 3x. Once again, need to subtract these. 3x minus 3x cancels. Negative 16 minus 15 is negative 31. So here our quotient is 4x plus 3, remainder 31. Since we have a remainder of negative 31, we could say that x plus 5, which is what we were dividing by, times 4x plus 3, which was our quotient, plus negative 31, or minus 31, would be equal to our our original polynomial, 4x squared plus 23x minus 16. If we wanted to check, we would multiply and subtract 31. Our key concept here: we can divide a polynomial by a polynomial to get a polynomial quotient. The polynomial remainder, r of x, is what would be left over. So if we have the quotient times the divisor plus our remainder, that would be equal to our original polynomial. If our remainder is equal to 0, then our polynomial is equal to the dividend times the quotient, because those are factors of our original polynomial. When we're using long division, we need both our original polynomial and what we are dividing by to be in standard form, and any missing terms. So say we had x cubed minus 5. We're missing the degrees of 2 and 1. We would need to write that as x cubed plus 0x squared plus 0x minus 5, so that we have every placeholder. When we're done We know we're done because the degree of what was inside our division is less than our divisor. And then if there is anything remaining, that is our remainder. In order to check for a factor, we need to see if our remainder is equal to 0. So we're going to write 3x to the 4th minus 4x cubed plus 12x squared plus 5. And here, since I have x squared plus 1, I'm going to write x squared plus 0x plus 1. And I always look at my first term of my divisor. And how many times does x squared go into 3x to the 4th? And I would need to multiply by 3x squared. So I line it up with the place value and I multiply. 3x squared times 1 is 3x squared. 3x squared times 0x is 0. 3x squared times x squared would be 3x to the 4th. Once again, subtract everything. So I get 3x to the 4th minus 3x to the 4th canceled. Negative 4x cubed minus 0. And 12x squared minus 3x squared, which is plus 9x squared. I can bring down my last term, which is plus 5. And what do we need to multiply x squared by to get negative 4x cubed, which would be negative. Oh, I'm so sorry, I've missed a placeholder. I'm missing the place value of 0x, so I'm going to add that in. And I'm going to bring down 0x here, so that I have plus 0x. And now I can line up the negative 4x. And now I'm going to multiply negative 4x by x squared plus 0x plus 1. So negative 4x times 1 is minus 4x. Negative 4x times 0 is 0. Negative 4x times x squared is minus 4x cubed. I need to subtract, so I'm taking the opposite. Negative 4x cubed plus 4x cubed cancels. 9x squared minus 0 is 9x squared. And 0x plus 4x is plus 4x. Now, what do I need to multiply x squared by to get 9x squared? And I need to multiply by 9. So plus 9. I have to bring down my plus 5 as well. And now I multiply 9 times my entire divisor. So 9 times 1 is 9. 9 times 0x is 0. 9 times x squared is 9x squared. And subtract. 9x squared minus 9x squared cancels. We're left with 4x minus 4. Since 4x minus 4 has a lower degree than x squared plus 1, the remainder is 4x minus 4. And since we have a remainder, this is not a factor. Is x minus 2 a factor of p of x is equal to x to the 5th minus 32? If it is, write p of x as a product of two factors. Use the factor theorem to determine if x minus 2 is a factor of x to the 5th minus 32. The factor theorem states that if we are dividing by a binomial x plus or minus a, then if this value, the opposite of this value plugged into your polynomial is equal to 0, then x minus 2 would be a factor. So we need to take the opposite of 2, negative 2, which is 2, and plug it in. So I have to do p of 2 is equal to 2 to the 5th power minus 32. 2 to the 5th power is 32 minus 32. So p of 2 is equal to 0. So since p of 2 is equal to 0, x minus 2 is a factor of our original polynomial. You guys right now are going to do the long division to find our other factor. So you're going to do, oops, sorry, x to the 5th. But now we need placeholders here, so plus 0x to the 4th, plus 0x to the 3rd, plus 0x squared, plus 0x minus 32, divided by x minus 2 as your u triad. See you tomorrow.